So let's have a look and we'll see how we can manipulate functions. We have this function here which is f of x equals x squared. Now we're going to move this function about and stretch it and squeeze it. So if we think about the different ways we can manipulate it, we can shift it up and down the y-axis. We can shift it left and right on the x-axis. We can stretch the whole surface in the x-plane. We can stretch the whole surface in the y-plane. We can reflect the function in the x-axis. We could reflect the function in the y-axis. We could also reflect the function in the line y equals x. So let's go ahead and we'll see how we're able to do these mathematically. So let's look at the first one here. So the first one here, we take the function f of x and we add a constant value a onto it. So let's go ahead and we'll add that value on. So you can see here the new function simply moves the old function up and down. So every x coordinate, every y coordinate, we add on a particular value. In this case it's 1. So 0 goes to 1 here and 1 goes to 2. And again the 1 here goes to 2. So this moves it up the y-axis. We can also put it to 0, which gives us back to, we get back to our x squared, and then we can go in the opposite direction, so we can go down the way into negative values. So that's the first one that we're going to look at. It's our first manipulation. So let's look at another manipulation. We'll call this f of x plus a. So we can see here that what this does is it moves the function left and right. So if we were to make this value a negative, then you'll see that by making it negative, we move the function to the right, and by making it positive, we move the function to the left. So now we're able to move the function up and down, left and right. So let's look at the next one here. So this is minus f of x, so every value for x now becomes the same value but with a minus sign. So for example, that height there 1 would become minus 1. That height there 1 would become minus 1. So that's equivalent to reflecting the whole function in the x-axis. Now if we look at f of minus x, now there's not a lot to be seen here. We only see what's happening if we use a different function. So let's try a different function. Rather than x squared, we'll put in 2x. So this is our function y equals 2x. Now whenever we put in f of minus x, we get this function here. So what this does is it mirrors the function, or reflects the function in the y-axis. Now we'll have a look at the last two, but for the last two we'll again use a different function because it's much easier to see what's happening. So that's the function y equals sine x. Now if I was to multiply that function by some number a, what that does is it stretches the entire function in the y direction. So you can see the function getting stretched. So in effect we're amplifying the function in the y direction. Now we could do the same thing, but it would be f of ax. And this f of ax, we stretch and compress the function in the x direction. So that's a compression of the whole plane in the x direction and an expansion of the whole plane in the x direction. So this has looked at all the different ways that we're interested in for the moment of manipulating a function. So we'll go ahead now and we'll look at this mathematically.